Again, you guys, when you're out, remember I have to mark you absent if you're not sitting in your seat or you're not on the Zoom. Okay, I have to mark you absent. That is my job. I do not correct that until the following day, and a lot of times that doesn't happen until third period. I try to get y'all's done as soon as I finish doing Zoom. Um, so if you see that absence after today, then yes, say something about it. Otherwise, there's no point in you emailing me. Like I keep getting a lot of emails. Oh, you counted me absent, but I did my work. Yes, because you weren't physically in your seat or you weren't physically on the Zoom. If that's the case, you will get an absence and I will correct it. So Friday, those of you that weren't on the Zoom, as long as you took your test, I'm going to go back and correct that. But it's when I get to do it. Okay. So again, I try to do y'all's right after I do Zoom. If I'm not helping anybody, and then after that, it'll be third period. So as long as it's done by the end of the day, you should be fine. So always check those absences. And if you find a discrepancy, absolutely email me. Be really nice about it. Remember, I'm taking attendance 40,000 times. So be nice about it and say, hey, can you check my absence on blah, blah, blah? Because I really think I was here. And it could be that I just pushed the wrong button at the wrong time. Okay. So don't stress about it. I don't want you to stress about it. I'm not going to stress about it. But again, don't be mean to me. I'm doing my best. So just be nice about it, and I will fix whatever I can. Also, remember if you are out for any reason, like you're sick and you could possibly be quarantined or anything like that, we understand that. Okay, so you be out and you're fine. And if you actually are quarantined or anything like that, you send documentation in through the school and they will waive those. Okay. So don't stress about that either. I do appreciate those emails like, hey, I'm not going to be here, just letting you know. Like it might be a while before I come back. Just, I don't care. I don't need to know that. That is not my business. But I do appreciate knowing because I do worry about you guys. So, um, anytime you're out like that, you will get absences. You will accrue absences if you are not physically in your seat. If you're remote, it's just like always join the Zoom, you're good to go. All right. Otherwise, you just send in the documentation and those absences can be waived. All right. Hopefully, with the right documentation, they will be waived. All right. So, we're going to go ahead and get starting on analyzing piecewise. So, a function is increasing on an interval when its y value increases from left to right. Remember, we read a graph left to right. So we read it just like we read a book. Let me get this so you guys can see it. Same thing, it's decreasing on an interval when its y value decreases from left to right. A function is constant on an interval when its y value remains the same. Okay? So that means it's going to be a horizontal one. All right, so two things that you're going to see that you may not have seen in previous years is a relative min and a relative max. You've seen a minimum and a maximum, right? Y'all know what minimums and maximums are. A relative min and a relative max just means it's not the only one. So there might be a minimum and a maximum. So your graph might look like this, and it'll have a maximum and a minimum. So instead of just saying what's the max, what's the min, they say what's the relative max and what's the relative min. There's absolutely no difference in it. It just means there's more than one. Okay. So there's not just a specific minimum. There could be a minimum and a maximum. Got it? So relative min is the point where the function changes. So if it's a minimum, it looks like this from left to right. From left to right, it decreases and then it increases. So it changes from decreasing to increasing. Guys, we need to make sure we're on time, please. Some of you are late habitually. Please be on time. A relative maximum. A max looks like this. So when we start on the left, the graph is increasing, which means it's going up till it gets to that point. We call it a turning point. And then it becomes decreasing. So it changes from increasing to decreasing. All right. So here's our first example. We have a graph and then we have all these questions. It says state the open intervals. What does that mean? Open intervals. We're going to use parentheses. I cannot write today. Y'all write bad on Mondays after you haven't written all weekend? That's how I feel right now. So I apologize. The next one says where it's decreasing. There could be different intervals, and we'll talk about that in a minute. State the domain and range. We're going to state the coordinates of any relative min, any relative max, and then we're going to write the piecewise function. Okay, we're going to write the piecewise function. So here's what I want to do. I'm going to use highlighters so you can see. If you would like to use highlighters, that's fine. 2 or 3 will work. 2 should work for right this second. So we're going to start on the left. Remember, we read left to right, and I do A and B at the same time. That's just me. That's how I do it. I do A and B at the same time. So I'm going to start, and we're going up. So that means our function is increasing. Okay. So it's increasing. So this one is increasing. So I'm going to make it yellow. On the left, we have an arrow. So it's just kind of like domain. We're at negative infinity. And then we always use the x's. What is the x coordinate where it reaches that maximum point? What is the x coordinate for this coordinate right here? -1, thank you. That is our turning point. At that point, it starts decreasing. So I'm going to use pink for decreasing. And that decrease started at -1. And the reason we use open intervals is because that -1 is neither decreasing or increasing. So we put it in both. So that's why we open it. Okay, so we're not using brackets on this. And then it stops decreasing right here at this coordinate. What's your x coordinate? 1. And then it starts increasing again. So where does it increase? It started at 1, and it goes all the way to, this looks like 7. That's the only new stuff that we should know. Okay, that's it. That's the only new stuff that you have today. Everything else you should be fine with. So we're going to do domain and range. Okay, so I'm going to start with domain. I'm going to try to put it on the graph so you can see it. Starting on the left, where does it go to? Negative infinity. Again, if you use your Post-it notes or whatever, on the left, I have an arrow negative infinity. I don't see any open points, but then I see a stopping point at what? Where was that stopping point? 7. Open or closed? Closed, because it's a solid point. On your test, and remember, you can go back and take it. You can go back and try it again. Open and closed intervals are killing you on your domain and range. Not the numbers. The numbers look great. Normally it's the numbers, but it's the open and closed. So watch those. Okay. All right. Do your range. What's the lowest this graph goes? Negative infinity. It goes up. I don't see any holes. And it looks both of these are on what? What's your highest? 4. And they are solid points. So we close it up. All right. Remember, to be a minimum or a maximum, it has to change direction. So the reason I tell you that, you know that this is a max. This one is a minimum because we have 2 different highlight colors, right? You guys see that? It goes from yellow to pink, pink to yellow. This coordinate right here is not going to be anything. A lot of people try to use it because it goes up and it stops, but we don't have anything past it. It doesn't have a turning point. Okay, so if it is not a turning point, it is not a max or a min. So then you just list the coordinates. So the minimum is right here. It is at 1, 2. So your minimum is at 1, 2. And there could be more than one. Okay, there could be more than one minimum, could be more than one maximum, could be one of each, could be only one min, only one max. Just depends on the graph. And then your maximum is right here, and it's at 1, 4. So I'm going to write that down right here, 1, 4. And it's a coordinate, so it's open parentheses. All right, so now F says write a piecewise function for the graph above. We've already done that. You did that in your notes. We're going to review it, okay? So I'm actually going to do part F up here. We have two different functions. What kind of functions do I have? What are the different shapes that I have? I'm just getting another highlighter. What different, I'm gonna go ahead and tell you there's two functions on this graph. What are the two functions? What makes a U shape or an N shape? What function makes a U shape or N shape? Quadratic, so this side is quadratic. And then what's this side gonna be? It's just a line, so it is linear. All right, so this is the hardest part, okay? This is the hardest part right here. If you get it, then you're golden for today. Okay, I'm telling you, this is the hardest part. So what I do first, this is how I work it first, is I do my boundary line first, okay? So right now, we see that the quadratic is on the left of 1. How do I write left of 1? X is what? Less than. I can put equal to, and the reason I can put equal to is because everything's a solid point, and 1. So that gets our left side. How do I write the right side? How do I write bigger than 1? X is greater than or equal to, and I can write, again, greater than or equal to because that's a solid point on that line, okay? Don't stress, one of them has to be equal to, the other one does not, or both of them can be, okay? Just as long as at some point you have an equal mark because it is closed, all right? So then we're going to write the functions. Remember, your quadratic is the first one, it's on the left, and this one is your linear. So if you need to write that down, this one's got to be your quadratic. This one's got to be your linear. All right, so from here, I honest to God would do this in my calculator from now on, okay? We had to do vertex form on our test. You don't need to do vertex form. The only one your calculator will not do is absolute value, but that one is easy and we have one, so I'll show you how to do it, okay? So here's what I would do. I would go to my stat and edit. So I'm working on the quadratic. I'm gonna clear L1 out because that was my like AP stat stuff. So we're good. Is everybody good? All right, and I'm gonna put my coordinates in. What was this max coordinate? It was at -1, 4, right? Okay. Then I have this coordinate. This coordinate is at 1, 2. Is everybody okay with what I'm doing? I need 3 of them. So now I need another one. And they give me this point down here, and this one's hard to see, but I'll tell you that it is -5, -4. Okay, so pick 3 points and then do stat, calc, quadratic. Stat, calc, quadratic. You guys know how to make equations. You're going to do linear the same exact way. Linear just needs 2 points. Quadratic needs 3, linear 2. Got it? All right, so then when we calculate, it gives us our equation. Our equation was -1/2 x squared. It tells you -1/2 x squared minus x plus 3.5. Do not try to do this by hand. It takes too dang long, and we're done with that now. So remember, I told you the first unit was the one that I was going to make you do by hand. And then after that, it gets a little bit easier, right? So I'm gonna teach you how to do a lot of stuff on the calculator from now on. All right, so again, put in your points. And calculate for each, okay? So we're gonna put in points for our linear now. We can clear all this out. We don't need it. Look at your linear. This coordinate was 1, 2. The last coordinate was 7, 4. Is everybody okay with that? Stat calc, and then this time we're doing linear. What's 0.3 repeating? 1/3 x. And then plus, again, it tells you the equation up here, 1/3 x plus 1.67. Guys, if you give me the decimal, that is perfectly fine. If you go ahead and change it, that is fine. I don't care. This is 1 2/3 or 5/3. Okay, I don't care. Decimals to fractions do not bother me. Got it? All right, so again, put it in L1, L2, and then calculate it. So that is your piecewise function. All right, look at your next page. Again, I told you I do part A and B at the same time. I'm going to do increasing is yellow, decreasing is going to be pink. So when we first start, what do we have? Increasing or decreasing when we first start? Decreasing. Then at that turning point, which is going to be a max or a min, we go to increasing, and then we go to decreasing. What is that other line right there? What is that thing? We did it in our definitions. If it's a horizontal line, does it change? No, so it stays constant. So this is a constant, and it's not on here, but I'm going to write it down in just a minute. Okay. All right. So where does this graph increase? Where is it yellow? From what to what on the x-axis? Look at your x-axis. From where to where on the x-axis is it yellow? 0 to just your x's. 0 to what? 2. That's the only yellow that we have. Where is it pink? Again, only use your x coordinates. So where is it pink? Right here. What's that coordinate? -4, thank you. And then it stays decreasing until it gets to what? 0, very good. And then it picks back up, going decreasing at 2, and goes decreasing until 4. Always use x's if you need to write that. Always use x. I'm going to write this down. Your constant interval is from 4 to 6. So your constant interval is from 4 to 6, because I think they ask you that on your homework. So be ready for that, okay? All right, domain and range. From the left, start with your domain from the left. Where does it start? Is it open or closed, and what kind of 4? -4. Watch those negative positives. I saw some of that on your test too. It's closed, closed, closed until we get to our stopping point on the very end. What is that coordinate? How far to the left does it go? I mean, to the right does it go? 6. Perfect. And it is a closed point. What's your range? How low does it go? -6. How high does it go? Come on. What? 1. Thank you. And they are closed points, so you close it up. Okay, remember when it switches from pink to yellow or decreasing to increasing, increasing to decreasing? This point is a minimum. This point is a maximum. Here's what I'm talking about. It didn't go from pink to yellow, so this point is non-existent in relative maximum, okay? It's got to go from increasing to decreasing or decreasing to increasing, okay? So this one went decreasing to constant. That doesn't count, all right? So what is your minimum coordinate? I pointed to it. What is that actual coordinate? 0, negative what? 5, good. And then your maximum, what is that coordinate? 2, -2, very good. Thank you both. And then f is the piecewise function. So we're almost done. All right. What does it look like I have on this graph? What kind of functions does it look like I have? What do you think? Do I have any quadratics? No. Do I have any exponentials? No. So what could I have? I only learned 2 more. I could have absolute value. How do you know it would be absolute value? What's that graph look like? A V. So we might have 2 absolute values here. We're not real sure. Or they could be linear. They could all be linear. So here's how you tell. This is very important, okay? To tell whether it's linear or absolute value, you have to check the slope. So if we look at this graph and we check our slope, we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. If we check this one, we have 2 and 3. So our rise was 6, our run was 4, which is 3/2. You guys see that? What's this one? If it is the same, it's the absolute value, okay? So here, let me see that orange one. Is an absolute value. And again, the only way you know is to check, to make sure that you check the slope. If you look at the next one, it's a rise 2, run 1, so it doesn't have the same slope. So then you're going to split it there as well, and you actually have 1 absolute value and 2 linears, okay? 1 absolute value and 2 linears. All right, so I'm going to write this a couple different times. On the left, we have an absolute value. In the middle, we have a linear. And on the end, I'm just going to call it a constant so you know the difference between them, okay? Where is the absolute value graphed? It is on the left, so that means it's less than. And what is it less than? What is that first orange line from the left? What's this line right here? Where is it at? 2. So x is less than 2. Can I put equal to? Yes. All right. Where is this pink linear graphed? In general terms, where is it graphed? Between 2 and 4, right? So that's how we're going to write it. 2, the graph is between, and 4. These are always less thans, always. Again, for now, I would just go ahead and put equals on them. They're all solid points, so it doesn't matter. And then where is your constant? It is from 4 and on, right? Right? Excuse me. Sorry, y'all. So how do I write that? It is bigger than 4. Now, here's what I want you to understand. This is not completely correct. Why? What happens right here? It's a dot, right? So it really stops. So this one should be between 4 and 6. So technically what we should have is this, but I'm going to leave it at that. You can make it an arrow, whatever. Watch that when you write them. All right. So then now we have to figure out what they are. Remember how I told you the first one had a slope of 3/2, right? That absolute value. So this is how it's going to start. 3/2. You're going to have absolute value of x. What is your vertex? What was that minimum? What was your minimum? 0, -5. That's your vertex. So plus 0 minus 5. I don't care that you put the 0 in right now. When you give it to me, if you want to clean that up, that's fine. If you want to leave it, that's also fine. Remember, if it were something like 1, -5, when we put it inside of that absolute value, it's got to change signs. Okay, so this one didn't have to change because it was 0. And then x is less than or equal to 2. The linear, you can put your, sorry, it's these two. You can put your 2 points in. Again, absolute value is the only one that your calculator will not do. So if I'm doing linear, I'm going to go to stat and edit. My first coordinate was -2. My second coordinate is 4 and -6. 4 and -6. Is everybody okay with putting it in? Stat calc, linear regression, so I don't have to do any of the work. And I get -2, 2. So my equation is -2x plus 2. And that's between 2 and 4. The last one is constant, and you absolutely can put that in your calculator as well. You shouldn't need to, but if you do, it's okay. So we had the 4, -6, and then we had 6, -6. So stat, calc, linear regression, and it'll show you that your constant is actually -6. Again, you don't have to put it in your calculator, but if you forget how to write that, and that was between 4 and 6. But again, if you gave me greater than or equal to 4, I would accept that too. I understand. Okay. Any questions? Again, that part is the hardest. Okay. I think you have 1 or 2 functions on your homework. It's not terrible. I don't know. I lied because I think Ms. Gordon changed it last year. So we're done with this. Tomorrow we're going to start talking about solving and graphing absolute value equations. And as long as you can solve them, you're going to be okay. So like if you can solve regular equations, you're going to be fine. So I'm going to stop sharing and stop recording for a minute.